Good morning, students. Today we are going to start next part of metals and non-metals. You can see this reactivity series. The arrangement of metals in a vertical column in the order of decreasing reactivities is called reactivity series of metals. In reactivity series, the most reactive metal is placed at the top, whereas the least reactive metal is placed at the bottom. This reactivity series is very important for the reactions which we are going to study in our next slides. Now see sodium, potassium, sodium, calcium. These are highly reactive. Magnesium is less reactive. Aluminium, zinc, iron. Okay, so accordingly their reactivity is going to change our products. Now see in this reaction of metals with water. Now as I told you, reactivity series is very important. When you are taking any active metal, okay, any highly reactive metal, you get metal hydroxide and hydrogen. If you are taking less reactive metal with steam, or there is no need of steam or hot water for highly reactive metal, right? So in metal plus steam you get metal oxide plus hydrogen. Please see, metal plus water we get metal hydroxide plus hydrogen, and when we replace that water with steam we get metal oxide plus hydrogen. Let's start with few examples. In this picture you can see this flame, and this flame is because of the burning of potassium. Okay, when small piece of potassium is placed in water, it catches fire because in reactivity series it is the topmost metal. So this is the vigorous reaction. Potassium reacts with water and we get potassium hydroxide, water, and lots of heat gets generated. Next, sodium plus water. Again, sodium is highly reactive. So, here we get sodium hydroxide plus hydrogen and heat. Now, see why do we get flame, or why this reaction catches fire? Because the hydrogen which we are getting at the end of product, that is getting fired, okay, that is getting catching fire. That's why heat get generated. Then calcium plus water. Now calcium, if you see in reactivity series, it's a third member. So calcium can react with cold water and we get calcium hydroxide, CaOH twice plus hydrogen gas. Now see in this picture, the calcium metal bubbles and fizzes in water to form calcium hydroxide solution and hydrogen gas. Much less heat is produced in this reaction, due to which hydrogen gas formed does not catch fire and burn. Now magnesium metal. Magnesium metal does not react with cold water. Magnesium reacts with hot water to form magnesium hydroxide and hydrogen. In this reaction, the piece of magnesium metal starts floating in water due to the bubbles of hydrogen gas sticking to its surface. Calcium reacts with cold water, but magnesium reacts only with hot water. This shows that magnesium is less reactive than calcium. Magnesium reacts very rapidly with steam to form magnesium oxide and hydrogen. Please note that when magnesium reacts with hot water, it forms magnesium hydroxide and hydrogen. But when the same magnesium reacts with steam, it forms magnesium oxide and hydrogen. Next, metals like aluminium, zinc, and iron do not react with either cold water or hot water. They react with steam to form a metal oxide and hydrogen. Aluminium reacts with steam to form aluminium oxide and hydrogen gas. Aluminium metal does not react with water under ordinary conditions because of the presence of a thin layer of aluminium oxide on its surface. Zinc reacts with steam to form zinc oxide and hydrogen. red hot iron reacts with steam to form iron oxide and hydrogen. Reaction of metals with dilute acids. Metals usually displace hydrogen from dilute acids. Only the less reactive metals like copper, silver, and gold do not displace hydrogen from dilute acids. When a metal reacts with a dilute acid, then a metal salt and hydrogen gas are formed. Metals react with dilute hydrochloric acid to give metal chlorides and hydrogen gas. See the examples. Sodium plus HCl means sodium metal reacts violently with dilute hydrochloric acid to form sodium chloride and hydrogen. This reaction shows that sodium metal is very reactive. Magnesium reacts quite rapidly with dilute hydrochloric acid, forming magnesium chloride and hydrogen gas. The reaction of magnesium with dilute hydrochloric acid is less vigorous than that of sodium, so magnesium is less reactive than sodium. Aluminium metal at first reacts slowly with dilute hydrochloric acid due to the presence of a tough protective layer of aluminium oxide on its surface. But when the thin outer oxide layer gets dissolved in acid, then fresh aluminium metal is exposed, which reacts rapidly with dilute hydrochloric acid. Thus, aluminium metal reacts rapidly with dilute hydrochloric acid to form aluminium chloride and hydrogen gas. The reaction of aluminium with dilute hydrochloric acid is less rapid than that of magnesium, so aluminium is less reactive than magnesium. Zinc. Zinc reacts with dilute hydrochloric acid to give zinc chloride and hydrogen gas. This reaction shows that zinc is less reactive than aluminium. Iron reacts slowly with cold dilute hydrochloric acid to give iron chloride and hydrogen gas. Copper does not react with dilute hydrochloric acid or dilute sulfuric acid at all. This shows that copper is even less reactive than iron. So when copper reacts with hydrochloric acid, there is no reaction. Okay. Now metals react with dilute sulfuric acid to give metal sulfate and hydrogen gas. Here in this table you can see all the reactions. We get metal salts which are sulfates. Sodium plus H2SO4 we get sodium sulfate plus hydrogen. Magnesium plus H2SO4 we get magnesium sulfate. Aluminium H2SO4 we get aluminium sulfate. Then zinc plus H2SO4 we get zinc sulfate. Iron plus H2SO4 we get iron sulfate. Copper plus H2SO4 no reaction. Children, if you see, copper is below hydrogen and therefore it cannot displace hydrogen from its acid content. When a metal reacts with dilute nitric acid, then hydrogen gas is not evolved. Nitric acid is a strong oxidizing agent. So, as soon as hydrogen gas is formed in the reaction between a metal and dilute nitric acid, the nitric acid oxidizes this hydrogen to water. Here you can see the reaction of magnesium with nitric acid. We are getting magnesium nitrate and hydrogen. Manganese reacts with nitric acid to get manganese nitrate and hydrogen. This is possible only with magnesium and manganese when we use very dilute nitric acid. See here in this reaction, as we are using very dilute nitric acid, then it becomes poor oxidizing agent and it doesn't oxidizes hydrogen to water. Thank you.